This is the last section, 8.8 in chapter 8, solving a multi-step equation and inequalities. So this will probably be the most difficult that they are going to get. So it's very similar to what we did last time. This just has one more step prior to that. So we're going to draw the divider line down from equals. Notice on the left side and the right side you have parentheses with a number out front, so we have to distribute this number first. So that's 20x plus 50 equals 30x plus 15. And this is like what we saw in a previous lesson. So we got x terms and number terms on both sides. We need to collect our variable terms to one side and the numbers to the opposite side. So first I'm going to take away 20 x's from both sides. The only thing left on the left side is 50. 30 minus 20 is 10 x's, and bring down the plus 15. Next step is subtract 15 from both sides. So you have 10x and 35. And lastly, just divide each side by 10. So you get the x value is 3.5. This also says to check our work, to check your solution. So off to the side, you're going to rewrite the original problem, which was 20 parentheses x plus 2.5 equals 15 times 2x plus 1. Okay, so I'm going to replace these x's with my answer of 3.5 and see if it checks out. So 20 parentheses 3.5 plus 2.5. On the other side, you have 15, 2 times 3.5 plus 1. Okay, so on the left side, order of operations, you do parentheses first. So 3.5 and 2.5, that makes 6. 20 times 6 is 120. On the right side, you have 15 in parentheses. 2 times 3.5 is 7. Add 1 and you get 8, and 8 times 15 is also 120. So our answer checks. Sometimes you'll have special solutions. So some equations have no solution, and this is when you have the null or the empty set. So you can use the symbol which looks like a 0 through a slash through it, or curly braces with nothing in it, because there is no real number that you can replace the variable with and it would make the equation true. Other equations have every number as their solution, and this is an equation that is true for every value of the variable. Is called an identity. So one of each of these will be displayed in these next two questions. So part A, again, draw the divider line. I'm going to distribute 3 first. So that's 3y minus 15 plus 25 is equal to 3y plus 10. I'm going to simplify that left side so I can combine like terms. The negative 15 plus 25 turns into 10. So you have 3y plus 10, and that equals 3y plus 10. We should notice that these sides are identical, which means this is an identity problem. And your solutions are all real numbers. So any number I could replace y with, and the left side and the right side will be equal. On part B, we're going to distribute the 2. So this is 4s plus 6. Bring down, subtract 9s. I'm going to collect my s terms on this side, include that negative sign with the 9s. So you got negative 5s minus 14. On this side, you got negative 5s plus 6. I'm going to continue. I see that the negative 5s is identical, but the 14 and the 6 are not. So if I add 5s to both sides, you get negative 14 is equal to 6. Well, we should know that is never true. That's an always false statement. So this means there is no solution. There is not any number for S that we can substitute in and have the left side equal to the right side. So this one was all real numbers. This one was no solution. And lastly, we're going to solve a word problem. So Mariella's parents have budgeted at most $575 for her quinceañera celebration. The cost of the party room is $75. How much can the family spend per guest on food if each of the 40 guests receives a $5 favor? So my unknown in the problem is how much can the family spend per guest on food? So that's going to be my unknown variable. Let's see, equal cost per guest on food. All right, because it says at most $575, I'm going to use the less than or equal to inequality sign because I can't go over my budget of $575. That's the max I can spend, or anything smaller. So the cost of the party room is $75. And you're also going to add, there's 40 guests going, and they're getting food and a $5 favor. So you can set it up like this. Distribute the 40. So 75 for the party room. 40C represents the amount of food for each 40 guests. And 40 times 5 gives you 200, which is spent on the party favors. And that has to be smaller than or equal to 575. To solve this, I'm going to combine the 75 with the 200. They're on the same side, so that makes 275 plus 40C is smaller than or equal to 575. I'm going to take away 275 from both sides. So you get 40C is smaller than or equal to 300. Divide each side by 40. So C is smaller than or equal to 7.5. That's not your final answer, so always reread the question. How much can the family spend per guest on food? Well, if this is what you got as an inequality answer, you need to interpret that. So that means the family can spend at most $7.50 per guest on food. So they can spend $7.50, they can spend $7, they can spend $2 if they wanted, but anything that's $7.50 or less to stay within their budget of $575.